Hi, everyone. Welcome to the CS Colloquium at the Hebrew University. Today, we're very happy to have Yulia Tsvetkov with us. Yulia is a assistant professor at Carnegie Mellon University, where she also did her PhD. And in between, she did a postdoc at Stanford, and she will be joining the University of Washington later this year. Yulia is doing a very creative and interesting research on the links between NLP and ethics and social science. And today she's going to be talking to us about, and she's a recipient of numerous awards, more than I will list here. And today she will be talking to us about how can we prevent social and ethical problems in NLP systems. So without further ado, Yulia, the stage is yours.
Thank you very much for the kind introduction. I'm not recipient of numerous awards. So today is, I'm very excited. It's first time I'm giving a talk in Israeli University. I'm very excited to be here. Since I don't see your faces, please feel free to interrupt me anytime, just because I cannot hear you and I cannot see you. And I do have a little bit interactive slides in this talk. So this talk will be about the intersection of natural language processing and computational ethics. And in particular, I'll be talking about something that I call in this talk proactive NLP, how to prevent social problems before they propagate into our system and make our systems biased. Let's start with these interactions on some social media site. Let's assume it's Twitter. It can be any. And here is one type of interaction. Here is the tweet by a user. The user posts, "Do I look okay?" And the response is, "Oh, you're so pretty." So is it a positive or negative interaction?
Positive.
Thank you. Next question. Oh, no. So next question. Here is my new physics paper. And the users, this is another user. And the response is, "Why physics? You are so pretty." Is it a positive or a negative interaction?
Negative.
We don't know. It can be negative, but it can be a joke between the friends, right? So we're missing some context here to be sure. For many of us, it will seem like a negative interaction. What about this one? "Do I look okay?" And the response is, "Oh, you are so pretty for a black girl." Is it a positive interaction or a negative interaction? So I guess here there is, there is no doubt these are negative interactions, all kinds of manifestations of biases, even if the responder meant well, even if they thought it was a compliment. So if we think about technologies that are built on conversational data, like we have seen in the previous slide. So these can be conversational agents, they can be personal assistants, and these can be very specialized assistants that are just built on top of human-based interactions, medical assistants, educational assistants. And very often we use huge amounts of data to build such interactive conversational systems. And there is no way that a trained human moderator can check every possible interaction to actually target as a positive or negative what goes into our training data and what doesn't. The issue, as I presented here, is that very many of our interactions are actually riddled with social stereotypes. And the reason is simple. It's not only because of malicious users. It's because all of us are biased, whether we want it or not, because this is the way our cognition works. This is the way we learn to make generalizations. And we are not always aware of our own biases. So these kinds of interactions propagate, have a kind of risk. There is a risk that they can propagate into conversational models. And this can lead to unintended harms. And occasionally such models can make big headings in news. And I present here something that you might have heard of in maybe past year or a little more. So the most famous one is Microsoft's Thai chatbot that picked up on hate speech within a couple of days and became, or even overnight, it became sexist and racist. And then later when GPT-3 was introduced, then and very quickly it got adapted to the type of interactions it has with users and started offering suicide advice. So it produced outputs that were just dangerous to show to users. And just a couple of weeks ago, the same happened in Korea. There was a bot that was designed very similarly to Thai chatbot. And again, very quickly, it became extremely homophobic. It had to be removed. So this happens again and again, and it is likely that it will happen again. We will see more such news. So why does it happen?
Can I ask?
Please.
Why this happened? Is it he learned this from data? The data contains.
Yeah, the way the systems kind of were designed is that they kind of expand their training data based on previous interactions with users. And actually a group of, in the case of Thai chatbot, the group of users, they quickly picked up on the fact that the bot can kind of reproduce previous interactions and actually explicitly attack the bot. But the design of the bot did not actually check whether interactions should be stored in the training data or not, should be shown to a user or not. So it's a combination of malicious users and the problematic design that doesn't take into account that people can interact in all kinds of ways. Okay, so basically now to generalize, there are several reasons why this happens today, more generally in systems that we see, not necessarily in these three bots that I showed before. And the first biggest reason, I think, is that today's language technologies, they take a data-centric approach. So we need a lot of data. If you, even non-CSO, non-NLP audience, I think you have heard about, say, BERT models or GPT-3, right? So unless I totally cannot imagine what, actually, I'm not sure that everybody heard about it, but these are kind of big models that trained on large amounts of data. So we need a lot of data to train good models, and we do know very well how to leverage data. But I hope these examples show that language is not only about data, it's about people, the way people interact. And language is a primary way in which we actually express what we know about the world, including our stereotypes. And these models, they do know very well how to leverage large amounts of data, but they do not know very well how to kind of incorporate all kinds of social and cultural contexts, understanding who are the people that say a sentence and why do they say a sentence, so some intent, who are the people involved in interactions. So we don't know, basically, for very similar interactions, like I have shown in this slide, what types of interactions are socially appropriate or inappropriate. And then again, large kind of neural systems, they are very good at picking up all kinds of correlations, including the spurious correlations. And kind of because many of us, we share the same types of stereotypes, for example, against specific marginalized groups, it is likely that they will appear more frequently in our data, very specific stereotypes, for example, racial stereotypes. And these models, they very quickly kind of identify these spurious correlations and overfit to them because these are confounders in the actual tasks. So we don't actually know how to demote well spurious correlations, these confounders. And finally, once we have the system trained, we don't actually know how to analyze it well yet because we use these very large systems, which are black box systems. So they are not interpretable. So it's not easy to probe the system and analyze its responses to all kinds of conditions. Also looking forward, because language develops, language changes, interactions change. So we actually cannot analyze the systems well, and also cannot foresee all kinds of possible interactions.
Can I ask a question?
Sure.
How sensitive are the models to the data set? Is it possible that you take another data set, which is also big, but you will get not that racist bot or something?
So yeah, it basically depends on the size of the data very much. Generally, the smaller is the data, the more sensitive the models are to the data sets. But even in very large models and huge models trained on billions of sentences, these models do overfeed to problematic correlations. Now, you can, like your question, I guess, is can we take different samples of data and see that some models do overfit and some models don't? Probably we can, but I don't see an easy way to kind of take trained models on different ensembles of data to subsets of data to ensemble the models to demote those spurious correlations, because these types of biases are frequent in basically in all kinds of free-form data, user-generated data.
Thank you.
Can I ask?
Sure.
Yeah. Is this a big problem? Because what we're saying is the model mirrors mirrors what we do, what society does. So if we improve society, our models will improve. Is it a big problem that our models behave the same way we do?
Exactly. Yeah, and this is a big philosophy. You are leaning towards the big philosophical questions, kind of who has the right to improve the models and make them not representative of the society. But in this case, as I presented, medical assistants, educational assistants, it is actually important to take care of those biases, not only because they are harmful to specific populations, because these models don't only learn these stereotypes, they also amplify those stereotypes. So it is a very known problem that in any machine learning system, right? If you have a kind of example for which models know the right answer, it will produce the correct answer. If you have a model for which, if you have an input example for which the model has high, like low confidence, or ambiguous example, problematic example in some way, the model will defer to a majority class. And this is why in the case of the specific stereotypes, what women do, what men do, that men are associated with doctors, women are associated with nurses, or all kinds of biases that are present in society, the models, every time there is an ambiguous input example, the model will defer to the majority class. And in this way, they amplify stereotypes.
Can I ask a question? You've been hinting that the bots which have gone rogue go rogue because they seem to prefer talking to hostile sources of hostile opinion. And is that because a learning model tends to reward more highly the people who are willing to interact with it, who are eager to interact with it? And I know that's a bias of Facebook and social media that try to reward interactivity.
So
maybe you're going there.
I don't think that the bot explicitly prefers to interact with certain types of interactions. In this case, in the case of the bot, the group of specifically malicious users attacked the bot. And that's why it memorized very quickly extremely toxic interactions. But overall, the way algorithms today are trained, even recommendation algorithms, right? They optimize towards, clicks, right? And more controversial clicks, more controversial, for example, titles and news lead to more clicks. So there are many, many ways in which these algorithms can pick up on and amplify all kinds of polarization, something that causes for people to get involved and to interact. So there is no something in the design of the bot that makes it prefer to kind of pick up on specifically negative correlation, but there is nothing in the design that prevents it from certain interactions. Does it answer your question?
Yeah, for now.
Cool. So basically, and the way we deal with these problems today is something that I call a reactive approach, in which we create reactive technologies like a Thai chatbot that was deployed, and there were problems in its design, and then we saw that it becomes harmful, and then we remove it, and we develop in the NLP community, for example, we develop all kinds of algorithms to debias models, to kind of identify problems in models that are already trained, and then develop algorithms to demote or to blacklist certain outputs. This is a plausible approach, but we are not paying enough attention to an alternative approach, which is a more proactive approach, in which we just build better data analytics to analyze data and go further up the pipeline before they build the model and before we deploy it and before it causes harms, and building actual tools for automatic moderation, tools that can scan language, understand who are people involved in interactions, and kind of try to analyze whether there is some problems in the data before we feed it into the models. So, and there are several kind of dimensions on which we need to take care of to be able to build such models. One is to build these types of data analytics that I described just now. And for this, we need to be able to incorporate social, cultural, and pragmatic knowledge. So like in the interaction, in the second interaction that I showed, we actually don't know if it's a positive or negative interaction. Maybe it's a negative, but maybe not. And the reason we don't know, because we don't know who are the people involved in interaction. So today we don't have kind of the notion of like built in the model, in the majority of models, of course, I'm generalizing here, but we don't actually know kind of how to represent properly what kind of cultural and social interactions are appropriate or not. And then on the modeling side, it is important to build approaches to the most spurious confounders. This is something that we don't yet know how to do in deep learning, in big deep learning models, but there is some research on it. And finally, on the focus on interpretability, so how to build more interpretable and analyzable model. And I will kind of go over each of those dimensions and say kind of where we are in the NLP today. So specifically for detection of offensiveness or kind of negative interactions, there was a lot of research in language technologies that focused on overt toxic language. So maybe many of you have heard of Perspective API. It is a tool that learns how to detect hate speech. So hate speech and in comments, in YouTube comments, is a very big problem. And there are tools that focus on it. But what we are missing is a lot of types of human interactions which have negativity, which is more veiled. So one example is microaggressions. So what is a microaggression? It is a comment or action that subtly or unconsciously and intentionally expresses prejudice attitudes towards members of marginalized groups. And as I show in this example, this is not explicitly hate speech, as we know it, and it's not explicitly positive or neutral or negative interaction. So another type of popular problems in NLP are related to sentiment analysis, whether a sentence is positive or negative. But in microaggressions, the sentiment can be also positive, like I showed in the very first example. So the sentiment does not necessarily correlate with whether interaction is positive or negative. it was shown that microaggressions are actually pervasive also in human interactions. And there was a lot of research that they can be even more harmful than explicit hate speech, because they reinforce problematic stereotypes and specifically target marginalized groups. So our tools today, we have either hate speech detection tools or sentiment analysis tools, but we don't have tools that detect implicit negativity or veiled negativity. Next, about social cultural knowledge. So toxicity classifiers overfeed to social attributes overrepresented in data. But very often the same kind of sentence can be positive or negative. The same sentence can be positive, interpreted as extremely negative, and can be interpreted as normal social interaction, depending on the users who are involved in the conversation. This is related to my second example in the first slides. So today we don't know how to disentangle this kind of interactions. And then later models overfeed to confounders. So it was shown that, like in these three examples, so the conversation with Amanda was heartbreaking, the conversation with Alonso was heartbreaking, and the conversation with Lakisha was heartbreaking. So this is exactly the same sentence that is fed into a sentiment analysis tools. But it was shown that these three sentences produce different types of sentiment. One of them can be tagged as a positive, and one of them can be tagged as a negative. And the only difference is they basically overfeed to African American names or Latinx names or American names, white American names. So there is a lot of confounders in existing data sets. And finally, the issue of interpretability. So I will skip to actual research because I stopped on questions. And so these are dimensions, and these are not orthogonal dimensions. So we cannot build good data analytics tools without actually incorporating some knowledge about people. And we cannot build good data analytic tools without being able to demose spurious confounders. And the same with interpretability and the social cultural representation. So these like 4 layers are intervened. And what I'm going to present is two of our papers that address several of all of these, but they mix all these problems. So what we are working on is some sort of new type of data analytics, which can be seen as a social bias analysis, that given a sentence, it would analyze who are the people involved in conversation. Is it addressed to a man or a woman? Is it likely to contain a microaggressions or some sort of veiled negativity? And it has a capacity to generate some explanations, or at least similar examples, maybe with more overt speech, to explain why this interaction can be perceived as negative. And what I'm going to present is 2 papers that work in this direction. And I say in advance that they don't fully address the problems that I described. These are kind of big problems, but they take initial steps in detecting gender bias or kinds of microaggressions, specifically in unsupervised way. And then they use active learning approaches to kind of fortify existing toxic detection classifiers and also generate explanations. So I start with the first paper, which introduces a causal framework for demoting spurious confounds to identify gender bias in interactions on social media. So our goal is to detect subtle gender biases, specifically in second-person text. So like in the example that I showed previously, in comments addressed to a person. And a natural approach that is taken in NLP to build, say, sentiment analysis tools or others is a supervised learning approach. So supervised learning approach, you would collect a lot of data, you would sample these examples, you define an annotation task, for example, to detect microaggressions, and then you would let users annotate it, and you build a classifier that says, is it sentence biased or not biased? So in the case of subtle negativity, of subtle microaggressions, this is a naive approach that does not work. And there are several reasons. First, and the biggest one, probably, that it is, we cannot, it is not easy to train human annotators, especially non-expert annotators like annotators on Mechanical Turk, to detect subtle microaggressions and gender biases. And the reason is because every annotator incorporates their own biases, and we are very often unaware of our own biases. And the second problem is that biases are subtle and implicit. So if we say go to Reddit or to YouTube comments or to Twitter and just take a sample on random and annotate this sample, there will be very few of such interactions. And because we don't have strong lexical sieve, like in the case of hate speech, we don't we don't have a lexicon of say derogatory word, explicitly derogatory words to filter, to annotate more likely end of sentences to contain this kind of interactions. The annotation task would be very, very expensive. So we change, let's change this problem and frame the task differently. So let's take an approach in which we don't have a supervision on whether the sentence contains gender bias or not. But what we do have is the gender of the person that posted the comment. And what we can do is we can look at the comments addressed to that person and collect those comments with a label of the gender of the addressee. So was this sentence targeted towards a man or towards a woman, for example, in the binary case of gender. And then we can train a classifier with a target label, which is a gender. And our input is the comment towards a person. And if our classifier can predict with a high confidence that the target, that the addressee is a man or addressee is a woman, it is likely that this comment contains some sort of gender bias. So again, the task here is our inputs are only comment towards the addressee without looking at the text of the person, responses to some message, and our label is the gender of the addressee. So it's kind of a natural definition of gender bias. Our model can learn if comments directed towards a person can kind of has some sort of high confidence of prediction of the gender of the addressee. I'm sorry, I have to close my window because there is, I'm sorry, 1 second. So there was a lot of noise. Okay, so as you can probably guess, there are problems with this approach, and I call this slide the naive approach. And the reason is because the comment towards a person, if they reveal the gender of the addressee, they're not necessarily indicative of bias, gender bias. So, for example, a comment that uses the word bra, our model is likely to learn easily that this comment is addressed towards a man. But this is just a gendered language. This is not a biased language. So the core of our technology, the core idea behind the technology is that we identify all kinds of factors that can be indicative of gender, but not indicative of bias, of negativity, and and we define them as confounds in the task of predicting gender bias. And we develop all kinds of approaches to demote spurious confounds. So what are possible spurious confounds? What do we want to control for in the task of predicting gender of the addressee. So we identify 3 categories. First is observed confounds. Observed confounds is basically the comment towards the person can be just a response to the original post and can show kind of content from the original post. And if the original post is highly gendered, the comment is likely to be also highly gendered, but it's not necessarily a biased comment. The second type of approach is latent confounds, like what are the social and cultural properties of people involved in the conversation, which we cannot even enumerate. But these properties of people, they actually have an influence on the conversation. And the third type of confounds is just overt indicators, like the word bro, or a name, which is, or a title like Mr. or Miss, which are indicate gender, but not necessarily indicate bias. So the first, yes, please.
Can I ask a question?
Sure, sure.
Do you distinguish between comments that are, for example, in the male versus female case, between comments made by men to men versus by men to women and vice versa? I mean, do you assume that men are more likely to make biased comments towards women than women are towards women, for instance?
So we we take this into account in the latent confounds. So we don't explicitly identify the gender of the commenter, because this information is already proprietary. So the way, like, we can have a corpus in which posters explicitly kind of identify their gender. And but we don't have this information for people who actually respond. It's already basically we trained this model on the data set of public figures for which gender is known, for example, politicians or actors. But we cannot take existing users and try to predict their gender and incorporate it into the model, because it would violate their privacy. So in this case, we define the second category, latent confounds. We define a latent vector. What are words that are indicative of individuals? And they would also capture properties of gender of the person and the addressee, but we don't do it explicitly.
Thank you.
Okay, so so the first type is observed confounds. So we assume a setting in which an addressee written a text, such as post on Facebook, and we aim to detect bias in comments replying to the original text. And the first factor that we need to respond to, we need to control for, is the context of the conversation. So the comments that contain reference to the original text might not necessarily be biased. They may be a response to the original text. So, as I mentioned before, Tori, that we train our data on comments directed to famous figures, public figures, for example, to politicians. And we know, for example, that female politicians talk about sexual assault more often than male politicians. And this is why also comments directed towards women also talk about sexual assault more often than comments directed to men. But these are, again, not necessarily indicative of bias. So what we want to do, we want to identify those topics which are overrepresented in the posters posts, take into account the context of a conversation, and make our data balanced, not necessarily to overfeed to those confounders. So we account for this using a technique called propensity matching, which is a method drawn from causal inference studies. And we basically balance our training data in a way that comments addressed towards men have similar distribution of the original text values as comments addressed towards women. So we take kind of every poster and match them with another poster of the gender based on the likelihood of comments to predict this gender. And we discard heavily gendered original text. In this way, we kind of match posts with similar indicators of confounding variables. So our training data is balanced. So in the case of sexual assault, for example, or of likely kind of words and topics that are more associated with female politicians versus male politicians, we do see that now these topics of sexual assault are not overrepresented in our training data because we did this kind of matching. So now we don't expect the model to learn features that are predictive of the original text of the original post values, because we broke this correlation between the gender of the poster and comments in the training data. So the second type of confounds that we control for are latent confounding variables. And these are all properties of people which are known to the posters, but we cannot enumerate them. For example, where are they from? Are they from Canada or not? Like in this example. So these comments may reference traits of the addressee, such as occupation, nationality. I'm not sure, did I draw this on the screen? Yeah, I don't, okay, sorry. Or, so it's not easy to enumerate all these posts that are of specific people. So, for example, if we cannot use also propensity matching for this. So, for example, if Elizabeth Warren is our data, we would want to match somebody who mentions a politician who is similar to Elizabeth Warren. It's not, and we cannot find a male senator with the same properties as Elizabeth Warren. So we need to kind of learn those latent confounds, which we cannot enumerate. So we represent this latent confound as a vector in our data. So to learn the associations between a poster and the words and topics that they are likely to use. So we build a vector for each addressee in the training corpus, for each word in the training comments. We compute association for this addressee with the words that they use. So basically we take a corpus of a specific addressee, person number one, and compare it to the comments from all other people from other posters. And we compare these to corpora and we say, what are the words and the topics that are salient to this person compared to all other people? And what we want to do, we want to create a latent vector of words and topics that are salient to this person and compared to all other people. And we want to demote this vector. So every time we learn a model to predict the gender addressee, we want to demote all other properties of this specific person that are different from their gender and that are salient to them compared to other posters. So, and then having for each person, so for each person X in our data, we now have a vector of a distribution of this person on words and topics that are salient to them. And we incorporate it into a neural network and train it in a GAN style system that has a Y-shaped output. On one hand, we predict the gender of the addressee. On the other hand, we demote kind of the model from memorizing these specific words and topics that are salient to this person. So we demote that vector. We demote it in a way that we learn to predict the gender, and we make the model learn to predict the distribution over words and topics to make it as uniform as possible. So the way to evaluate it is to train a base model that doesn't do any demotion, and then to demote specifically kind of these latent properties of a person, and see if a model trained on out-of-domain data actually outperforms the baseline. So because now we demote spurious correlations, properties of the poster, and out-of-domain data, we already don't have these properties of the poster. And in our evaluation, we see that basically after demotion, which makes after we make the problem actually hard for in-domain data, on out-of-domain data, the model actually outperforms the baseline. So I showed how to demote explicit properties of people, latent properties of people, and the final is just overt signals. So there are all kinds of titles and proper names which can be actually identified using lexicons. So these we also identify and replace. For example, a word bro would be replaced by some template, like a title, or word Mr., Miss, and Mrs. would all be replaced by some template, for example, title. In this way, we also hide the gender of the addressee. So overall, we build a framework to detect the gender bias in second-person comments. And we identify properties of the poster that can be balanced for two different genders. We identify the properties of people in the conversation, and we demote those specific properties, and we demote kind of explicit titles. In this way, we make the task for the model to predict the gender of the addressee very difficult. And if after all this demotion, we are still able to predict the gender of the addressee, we hypothesize that if the model has high confidence, it is likely already to pick up on signs of bias. So it is not easy to evaluate such a model because there is no large public data sets of gender bias. So what we do, we train our model on the comments, on Facebook comments towards politicians and actors, and evaluate it on totally out-of-domain data. We are looking at the website called microaggressions.com. And on this site, people report their recollections of microaggressions. They describe all kinds of interactions and sentences that were offensive to them. This is one of the sentences from my examples I actually taken from microaggressions.com. So the model is not trained to identify microaggressions. It is not trained on in-domain Tumblr data. It's trained on Facebook posts. Nevertheless, it is able to detect gender-based microaggressions with an accuracy which is substantially higher than the random baseline. And we look at what are characteristics of bias against men or women. In this case, we look at, we combine the lexicons of stereotypes with comments on Facebook towards politicians or towards actors that are predict the gender of the addressee with high confidence. And we see that in Facebook comments that are addressed towards female politicians, some high bias comments are likely to refer to their families, to their spouses, to their power and competence. And in the case of comments that are addressed towards famous actors, the comments are primarily focus on the poster's opinion. So we actually showed many examples in our paper in which the actress posts about a movie or something about her work, but all of the comments that we identify are focusing on her appearance. Okay, so what I showed in this first part is an unsupervised approach to detection of implicit biases. And our goal here was to figure out how to do the classification model in an unsupervised way, and specifically to develop technology on how to demote spurious confounders. So it's our focus was more on the technological side. How can we demote spurious confounders rather than focusing on specific domains? And this can be this type of framework. There is a lot of scope for technical improvement, of course. For example, understanding how to incorporate more information about cultural context, how to go from binary gender to just the understanding of a representation of a persona. So the person can have a dynamic identity, which is not only gender, race, or intersectional categories. So how do we represent the target person as a continuous vector, which is the persona vector, and still how do we demote possible confounders? And this work can be applied to other domains such as news articles or essays or job application, reviews of job applications, and so on. I wanted to confirm with Roy about time because it's already 48 minutes and I'm not sure I will have time to talk about the second paper. So maybe I should just stop on one paper, just because we had questions and I don't think we'll finish in 10 minutes.
Yeah, I mean, we have until 3, so I mean, it's if you think you're not going to maybe just give us the highlight or something.
Yeah, I can just give a highlight of the second paper.
Yeah,
so basically now we focus on toxicity classifier, for example, perspective API, to detect classifiers that detect hate speech. And we treat microaggressions, comments like in the previous examples, as adversarial attacks on toxicity classifiers. So, and we identify, so what we want to do, we want to identify comments that are labeled. We hypothesize that toxicity classifiers like Perspective API are not able to classify microaggressions as toxicity. First, because they contain examples of microaggressions in the training data that are labeled as non-toxic. And second, because they don't have enough examples of microaggressions that are labeled as toxic as positive examples. So what we do, we take existing classifiers and we identify mislabeled instances in their training data and also augment their training data with more labels of microaggressions. And we develop an active learning approach. And the crux of our approach is how to interpret classification decisions through the influence of the training examples on the classifier decisions. So existing approaches to interpretability cannot work because they only focus on salient words in the input and analyze what is an effect of salient words in the input instance on the classifier's decision. So what we do, we develop a new approach to interpreting neural networks in which, rather than focusing on salient on the words in the input, which can be all positive and the sentence can still contain microaggressions, instead, for every sentence that we feed, including the microaggression in the classifier, we look at model prediction, then track from the model prediction to parameters in the model, and then from parameters to the model to the training data. And we analyze what is an influence of each training instance on the model decision. And we sort the training data based on the influence of each training example on the model decision. And even if the model misclassifies a comment as a non-toxic when the input is a microaggression, we find that the most salient examples in the training data also are likely to contain microaggressions. So we sort training data on the influence on model decisions, and then when the model makes an error in prediction, we can take top K examples in the training data and use the trained annotators who actually are trained to understand what is a microaggression task to re-annotate those examples. And we retrain the model after we kind of surface misclassified, mislabeled instances. And we show that after one iteration or after several iterations, the model becomes much more robust to microaggressions. And I will I now skip the actual technical part. So I think I gave a gist, and I'm sorry, I don't have time to cover it all, but I also point to papers, specific papers if you're interested. Okay, so wrapping up, online text contains microaggressions and stereotypes, and the way we are not able to deal with them is not something specific to ethical NLP, but due to the way neural systems are being trained today, and that they are taking a data-driven approach rather than people-centered approach. And the way to address it is probably to incorporate more social knowledge and to develop approaches that are more robust to spurious correlations and also that more interpretable. Thank you. Yeah. So I spent more time this time on the introduction than the actual papers, but I think it's okay for the general audience, for the CS audience.
Thank you so much, Yulia. And let's first thank the speaker. Yeah, I think we have a few minutes for questions. If anybody.
I can ask a question. Can you hear me?
Yes.
Great talk, thank you. I was wondering, how would you consider for the first work, text that is either explicitly or implicitly linked with gender, but is not biased or offensive in any way, say texts about pregnancy or even stuff that is socially, there's some social preference, I don't know, but is not offensive in any way. Would you consider that as biased, or would that be a false positive?
This is where our model can make the right prediction or not, depending on whether we so the stage of latent confounders is likely to detect properties of the addressee that are related to pregnancy, because if these are their kind of personal properties that they talk about. But it is also likely, but if it's a comment that is, say, related to pregnancy of someone else,
yeah,
it is possible that our model will make a mistake there.
Yeah.
Again, this is very, very initial model. Like it's really unclear how to detect this kind of very subtle negativities. And we present a very kind of first step, and there are many, many directions for improvement there. And this is one of them, yeah.
Yeah, and you can have like even second order biases. I don't know, sports more correlated with men for some reason, but it's not offensive.
Yeah, so these kinds of biases are actually, we check that they are captured by latent confounders, like all kinds of correlations that are correlated by people, that people tend to talk about in their conversations specifically. But this is, again, very, very noisy model.
Thanks.
It's a good question. Yeah, thank you.
Isn't the basic problem that what's considered biased is very, very subjective, and can be also cultural dependent? And it seems where, I don't know, you might be trying to catch wrong speak by people and educate people in a way that it's too, I don't know, too harsh, perhaps you'd say.
So there are two sides of question. One is about the general kind of the problem of subjectivity or bias, and the second is about specific our kind of approach. So yes, bias is subjective and culturally dependent. And probably the way to, it's like a very difficult problem how to identify it. And kind of a longer term, really interesting solution, I think, would be to build the knowledge bases, which actually analyze what are social roles of people and what are social interactions and language associated with specific interactions to understand what is right and what is wrong for specific social roles. And then to use this kind of knowledge base to incorporate it into the system to make it more informed and specific and informed about people and about cultures. So this is kind of a longer term solution. And the question is whether we are being too harsh. So the model that I presented, it's again the first step, and it is not near to the point when it can be deployed. At this point, we are developing technologies to detect confounders and demote them, for example, or to develop technologies to facilitate interpretability with applications to socially oriented problems. But overall, how to deploy these models, it's a very big question for experts in human-computer interaction. And basically, it's a more interdisciplinary solution on how to deploy it properly, not to be too harsh, to take into account different kind of what is appropriate or not. Also, when we kind of plug a model that detects some negativity, it can have all kinds of negative, harmful consequences, because people might decide to post less, for example, to people to whom this model fires more, right? And then it excludes those people from the web, from the participation on the web. So there are all kinds of consequences of the wrong deployment of this model. The model being too harsh is only one of them. And how to actually deploy is a heavily interdisciplinary solution. Does it kind of lean to answer your question?
Well, my question was, aren't you sort of trying to impose, let's say you're the writer of the algorithm, aren't you imposing the way you speak on everyone else? Perhaps you view something as negative, other people don't view it as negative. I'm saying the whole field is subjective, so it's not so clear what you're trying to do. You're imposing your point of view on others.
So this is why we did not actually create our own corpus of microaggression, but focused on detection of microaggressions, which are recollections of people, which were considered as very offensive. You're right. Like there is a big discussion on where is the boundary also between the hate speech and free speech, right? I can be very much against vaccines. I can be very much against Black people, and everybody who will tell me don't post hate speech, I can say you're imposing kind of your worldview, but I have a right to have free speech. And then the question is, should the systems actually kind of allow all kinds of free speech? Because there is also free speech that causes, like encourages people to commit a suicide. And yeah, so the question that you ask is, again, a philosophical question. It's an interdisciplinary question on how this should be deployed, how the model should be deployed. In our case, as kind of experts in machine learning and NLP, we developed technology to be able to demote spurious confounders, to make the models more interpretable specifically for social issues. But I actually don't know how to properly deploy it, right? Because it's a much bigger question.
Okay, I think we're out of time. Thank you, Yulia. This was a very, very interesting talk, and I think it left more open questions than answers, which is a sign of a good presentation, I think. And thanks again for coming over, especially in such an early time.
Thank you very much for inviting. It's good to see you guys, and I hope to meet soon in some conference, actually in person.
Okay, so,
yeah, hopefully soon.
Okay, see everyone next week.
Thanks a lot, Yulia.
Thank you.
Really interesting.
Thank you.